Alright, you guys, here's a look at kind of the intro of what I'm going to do, at least as far as my exploration when I'm dealing with the students. I probably end up directing it because I won't know if I have the time for them to get to computers and explore it themselves. So there'll be an element of exploration, but it'll probably be me somewhat at the helm, or a student at the helm of the computer going through steps. But what I did is I used the GeoGebra's option for Parabola. If you notice under these options here, conic sections, I did Parabola. You need a point and a directrix, so you just need a line and a point. And then that's what the directrix is. And the directrix is the line that measured perpendicularly from this line to any point on the parabola. It's equidistant then from the parabola then to point P. And that's the property we're kind of investigating. So I made that, and then I started constructing some perpendicular lines so I could do a nice measurement from D here that I made to the parabola. And so I made a point there, found a way we're going to measure it. I'm also going to find the distance between point P, that focus of our parabola, and then I also, just making some key intersections, made a perpendicular line at P because I know that the distance from P to the sides of the parabola here has relationship with the distance from the vertex of the parabola to the focus. So I just wanted to get all these points available, and I made those intersections. I'm going to measure all these, and I thought it'd be nice to let the students kind of just see all the measurements between all these. And so I've inserted all these segments and colored them, and I have lengths that are marked inside here. And hopefully that the ideas will play around with this, and as I kind of expand this, I did all kinds of measurements on here, just various segments of important measurements, for them to kind of just come up with some relationships. And then now this is movable. Within this particular, I can move the focus around, and there's some constants. I'm always looking for things that are constant when you're doing a dynamic graph like this, and so I'm hoping they'll notice some patterns. We can establish some relationships between those. Maybe gives some way to describe this distance from vertex to P as some important value, and then now we're going to hopefully direct them toward the idea that if you take this distance from vertex to P and you quadruple it, you're going to get that distance across the parabola through that point P, where that distance there is half as big as the distance from point P measured to any perpendicular to any point on the vertex or on the parabola itself. Also equidistant is any, like I said before, there's this point from the directrix measured perpendicularly, if I can get that out, to the parabola here at any point. That distance then from the parabola to a point P, the focus, should be the same. And we'll just move this around until, maybe they'll pick up on some things. And those are some relationships that help them build on that formula, not coming from outer space. And then, like, you wanted to make some connections with the regular formula with ax times x minus h quantity squared plus k. That's all. That would be nice, but generally speaking, it's just kind of looking at these parabolic relationships, maybe looking at the implications of those relationships. So I don't know if this GeoGebra file has any interest to you, but that's one that I'm interested in using with the students, and I just popped it together. But yeah, GeoGebra has some nice ways to move dynamically. Tell me what you think. There's some other things on that lesson I need to identify with you guys, but I thought I'd throw this together real fast because I needed to plan for next week also.